Okay, so the topics for week 8 are a bit, it's a bit, can be a little different and new, and it's a lot of topics to cover. So let me know if you get confused at any point of time. So, but
Sure.
because of course, we have to finish it within like 1.5 to 2 hours. So we won't be going into a lot of detail, but you'll see that in today's script, I have put a lot of comments. So even if it's confusing at first, since you'll have these scripts for your reference, you can take a look whenever you are practicing these commands. All right.
Sure, sure, sure.
So let's start with week 8's, just a quick recap of what we were taught this week. So last week we started off with something called lists, and we saw that it's a little, it's sort of like a next level vector where you can store a little more information. It can have a sort of a hierarchy itself. So we'll just take a quick recap of what it is. So the list command is used to create a list, and I have these few that we'll be working with in the next few lines. So if I execute these, um, you can see that, so here, for example, x, it would look, so x and y, for example. So if I write x here, so you can see that this one has 3 elements, and the elements of a list are represented by this double square bracket. So it's 1, 2, 3. And then each of the elements has a length of 1 only, because they have just 1 element each, right? Similarly, you can have another list which has um, another 3 elements, but these are numbers this time. Now, put, if I execute the one for Z, so you can see here within list, there is just 1 element. So that vector is element 1 itself. So I've already executed this. So when we see, so you will see that the list has 1 element. However, that first element of the list is a vector, and that has
Vector,
three
yeah.
elements, right? Okay. And then of course, in vectors, you can only have one type of data, but in a list, you can have multiple types of datas. So here you have 5 elements. So the first one is a vector. The second one is a number. The third one is also a number. The fourth one is again a very long vector. And the fifth one is also a vector, right? So this is what it looks like. All right. Now, if you do want to convert the entire list into a vector, that's doable. So the simple command is unlist. It's the name is explanatory itself. So of course, if you unlist this one, it looks like a normal list of 3 elements: apple, banana, and pear. So that's very, very simple. It's intuitive. But suppose this complicated one, this one which has W here. So you see it has both numbers and characters. Can you tell me, if unlisting it, do you think it's doable? And if it's doable, what would be the type of data in it?
Ma'am, it may be character because
Okay, correct. You're right. Perfect. Yes. So you see all of this. So this was
correct, double
the
quote.
first
Yeah.
element, second element, third element, and this all was the fourth element, and this was the fifth element. So everything became one vector. And like you said, numbers and characters together give you characters. All right, cool. So this is just something which so this is a recap of lists. Now, we've seen in the past that you can combine vectors. So we have used the C function, or the combine function, to combine single elements into vectors, right? And we have also seen that if you have two vectors, you can also combine them one after the other. Now, you can combine lists also. So just this is a recap, that if you have a vector A, right, a simple vector, 1:6, like from 1, 2, 3, 4, 5, 6. And if you have another vector B, which is from 11 to 19, and if you just do a combine, then you get a longer vector. So a vector plus a vector combined with a vector gives you a vector. Now, going back to matrices, if you have these two matrices, so we have seen that you can combine matrices in terms of C bind and R bind, right? When you can place
Yeah.
columns next to each other, or you can place rows one below the other. And we've also seen that matrices are nothing but vectors which are arranged in a particular way. So some functions in R, they can read a matrix as a vector, right? So sometimes we had seen in the last couple of classes that it may be read column wise, right? So if we are combining matrices, not C bind or R bind, but C on these matrices, then you can see what happened here is that both the matrices were read column wise. So you see matrix here, if you read it column wise, it is 1, 3, 5, 2, 4, 6. So that is what it gave you here. Likewise, matrix N, if you open this, so it's 11, 12, 13, 14, 15, 16, 17, 18, 19, which is here. So, so you can combine matrices. It will not retain its original organization. So matrix and matrix combined give you vector, but at least you are able to combine the numbers. Okay, now if you combine lists on the other hand, so if we take two of our original lists here, you can combine them using the C function. And what it does is, so this was the first list, this was your
Yeah.
second list. So it just combined them. So no change in any formatting. The individual elements, they remained exactly as they were. It's just put one below the other. So in terms of, so for metric, sorry, for vector and list, the C function is behaving very similarly. But for matrix, it's doing something like that, but it's not something that you would expect. So most likely, so mostly this is not used. C function with matrix is not very commonly used. Okay. A very similar application, so the same thing that you did here, that can also be done using the append function. So for the word append means to add something to the end, right? But the append function has another advantage, that it gives you the option to add it even in between. Did you have a question?
No, no.
Okay, all
Okay.
right.
Actually, my
Yeah, all right. So for example, so we had this vector, right? So if I write append a5, then it would mean add a, or instead of 5, let's say if I would write just 10. So if I say append 10 here, then you see it's added at the end. So it's almost like the combine function. I could have also written C a comma 10. That will also give me the same thing. If I write append a comma hello, then again, just like C a comma hello, it added hello at the end. And since of course a vector can only have one type of data, so everything became a character. Now this is where the advantage of append comes. So I write on the a vector, you append hello, but you do it after the first index. So this is the first one. Now after this, so that is between 1 and 2, you put this number 10. So if I run this, you see this is what happened. Between 1 and 2, it input hello. Likewise, if we are talking about the list, so this was our list, 3 elements. If I say I want to append 5 at the end, then it has appended 5 at the end, right? So now there's a fourth element here, which is 5. If I do hello here, then yes, the fourth element becomes hello and none of the elements are affected. And if I say you append hello after the first index, then the second index becomes hello and then the other ones get shifted. All right, is it fine till here?
yes, ma'am. Yeah.
All right, okay, great. Okay, now if you remember, we've seen extensively in some of the previous weeks how you can, from a vector, you can select some positions, right? So for example, if you had vector b here, so if you only want to choose some position, let's say position number 3, you can simply write b and in square bracket you can write 3. So that's how you can create a sublist or you can extract something from it. Right? Or you can even do this. If you want to extract 2 positions, you specify the 2 positions, but it there has to be just one specification, right? So this is one specification. For matrix, you have to have before the comma and after the comma, right? But here it should be just one single thing. So that one single thing can be a vector. So here, if I write this, then I've extracted the third and fifth element of this vector B, right? Now I can do the same thing using for lists also. Now here is a very important thing to note, and it's a major similarity or difference, however you want to say. So we've seen
Ma'am,
that in, yes,
yeah, ma'am, like if you want to extract 3 to 5, then
if you want to extract
uh,
3 to 5, think about it.
yeah, yeah. So 3 semicolon 5,
3:5, yes.
3, sorry, 3 colon 5.
Yep,
Yeah,
perfect.
yeah. Okay. Thank
Yes,
you.
yep. So yes, so this is how you would do it for a vector. And when you want to do it for a list, you have to do the exact same thing. So although in list we are often using this, we are often using the double bracket, but when you want to extract and retain the list format, you don't have to use the square bracket, the double square bracket. You have to only use the single square bracket. So same syntax. That is this rather than this thing. So this is important. Now we'll see what I mean by this. So here you have this is your vector W, right? This complicated one, this long vector. So now if I write W, so of course now you remember what this was doing. If I just did W in double bracket 3, so here now I no longer have the list with me, right? It's what the third element of the list is, but that third element itself is not a list. Do you see what I mean?
Yeah, yes, yes.
Right? So to make it more clear, if I do this, now you see what happened. The third element got returned as a list.
Yes.
So the
Here only the third elements are coming.
yes, so third element was just
Mm.
2, right? So maybe more clear would be, let's say if I take 4 instead. So if I just write double bracket 4, then you see I got a vector. I got the fourth element, which was the vector. But I want the fourth element as a list. I want a small list which has just one element, but it should still be a list. So now you see when I did this, I got a list,
Yes.
right? So again, we'll see a little bit more about this. So let's not do this. Okay. Now again, when I say, so here also, this was one element, and this was, let's say, when we were doing multiple elements. So let's say here also, if you want multiple elements of the list, then this is how you'll do it, right? You want to extract the
Yes.
third and the fifth element. So this is the first element of that new list. This is like, yeah, this is the first element of the new list, and this is the second element of the new list. But it still has the identity of a list. If you want to see the structure of this, you can see you can do str of whatever thing. Yeah, it'll show list, or you can do like a mode. So yeah, it says list. So you can check here also, mode of, let's say, this thing.
It
And
should be corrected.
yes, absolutely. So yeah, numeric, because it was,
Acha, 4 is numeric. Yeah.
yeah, this thing numbers.
Mm.
Yeah,
Hmm. Mm.
this thing is list. Correct? So
Yes.
now if I do this here, just to check, it would give an error, because there is no such thing within a list, right? You can't extract sort of third and fifth positions at the same time in terms of this double square bracket. So it doesn't work. R doesn't understand that. So these two lines summarize what we saw, that if you want to retain the list structure, whether you want to extract one element or more elements, you have to use a single square bracket. And when you want to extract one particular element and lose that list structure, then you use a double square bracket. Okay.
Yes.
Now I'm not sure if we talked about this earlier, but you can also remove elements. So let's say you have a list which has 100 elements. Suppose you want to remove the 65th element from it. So one option is you write which elements you want, or the other option is you specify which element you don't want. So sometimes writing which one you don't want is quicker because it's just one or two, right? So for example, when we are talking about vectors, so this was our vector B. If suppose I want to remove this value from it, so this is the third element. So I can simply write -3. If I do that, you see, I did away with the third element and got a new vector, right? I can also do the same thing when I have multiple elements that I want to remove. Suppose I want to remove the third and the fifth element. So I can write just as I would normally write. So this is what we wrote earlier also, right here. But I'll put a minus sign before the C. I could also write C -3 -5. That is also, I think that should also work. So either way, yeah. So either way, I'm removing my third and fifth element of the vector. Now, if I want to do for list, again, the same thing. Whenever I was wanting to extract or, retain the list structure, I have to use a single square bracket. So if I write -3, then so you remember this, there was this another element here, which was, I think, just 2 or something. So that is now no longer there. So I removed the third element from my list. This one again would not work. So yeah. And again, I can remove multiple elements also from the list. Again, it's the same syntax. Within the single square bracket, I'm going to write minus of my indices that I want to remove. So it's going to be like this. And again, this one would not work. So the double square bracket only works when you have a single element that you want from the list. And now it would no longer be a list. Okay. So,
Yes. Yes.
all right. Great. So that covers what was done in lecture 31. And so yeah, this was a relatively longer content. Okay. So now continuing lists here. So I have two more lists. Just give me a second. Okay. So again, this was the same list um, that we've been working with. That's W. And I'm making one more list V. Now, if you see here, the only difference I'm doing is I have the same elements, but I'm naming each of my elements. So what I'm doing is I'm instead of writing just my first element as C124, I'm writing E1 is equal to C124. And then I'm writing instead of 1, I'm writing E2 is 1. And then element 3 is 2. Then element 4 is this vector 1 to 100. And then element 5 is this vector of 2 words. Okay. So you can see V and W, they're both lists of 5 elements. And what they look like, so we had seen this briefly in the last week also. So typically you see that if you do not have any names, then this sort of a numbering is used. So even if, okay, all right. So yeah, so you see these numbers, right? The element numbers in double square bracket. Now, when I have given names, instead of the double square bracket, you get a dollar and name. So $E1, $E2, so on and so forth until $E5. Now, even though that double square bracket thing is not visible, you can still use it. Okay. So when I say W3, I get this. When I say V3, then also I get the same thing. So I can still access these using the same notation, right? So just what we saw in the last session, like 2 minutes back, if you have a single square bracket, you retain the list structure, right? So you have retained the list structure here. Now, if you want to extract the third element and you don't want to retain the list structure, then you use a double square bracket, right? So I can do that. I got the third element not as a list. For vector, for list V also, I can do the same thing. Now for this list, I have more options to call that name. So instead of using square brackets at all, I can write, so you can see what's going to happen if I write V and when I write dollar, you see it gave me all these options. So then I can choose. So that's how I wrote it. So that also gives me the same thing. Now one more complicated way. Sorry, question?
Yeah, ma'am, like here, dollar is just like we are using as a number. Like,
Dollar we are using, so you can see this dollar is already here. Yes,
dollar
I mean,
E5.
yes. So dollar is, so we'll see this dollar more often. So whenever there is a variable in R which has some sort of a structure, and within
Okay.
that structure, there are some named categories. So this is like a named grouping, right? Named element.
Mm,
So
yes.
to access those names, you use dollar.
All right.
Right? So yes, so you access the third element using the position, so that's 3 within the double square brackets. You access it using its name, which was E3, so $E3. And you can also specify this name within the double square bracket. So instead of writing 3, you're writing double quotes E3. So that also gives you the same thing. So you see that you now have 3 different options to access the same element. All 3 of them are same. All 3 of them are correct. It's up to you which one you prefer. So when you are writing 3, you need to remember what position it is at. Sometimes it's not very, say if you're working with something, some list which has 10 elements, you will not remember which position it's at. But maybe these names, since you have given it those names, maybe you will understand what the name is. So names are more useful. So it's very often it's useful to have names for these elements. Okay. And again, this is also the same thing
Yeah.
using the
So,
name.
ma'am, like if we are accessing two, like let's say 3 and 5, so we
Yes.
write $3
Okay.
E
Very good
E
question.
E3 I
Nice.
Mm,
So when you are accessing multiple, you cannot access multiple using double square brackets, right? So even with dollar also, you cannot access them.
yeah.
So yes, that's a good point. Um, can only access one list element at a time. So we just saw here, right? That when you're doing um, this double square bracket, you can't have multiple numbers within it. So the same thing here. So this will, you can only do one list element at a time.
All right.
So if you want to access, you can have like, you can do it twice and then make, so basically if you want to retain the list structure, then you still go with this format.
Okay.
So here you can still write, um, okay, so,
Dollar.
okay, I think what might help is this. Will this help? Yes, this will help.
Yeah. So basically, these are the two character. So okay, no. So here, to like our list is also maintaining their character. Well, like 1 to 3 is numeric, it's still showing numeric, and here is also numeric. So it's retaining their value character also.
Okay, let
Like
me.
earlier we have seen.
Okay, wait. I'll tell you something. So, list is not, when you're talking about lists, it's not affected by whether it's a number or it's a character. Everything stays independent, right?
All right.
So, that is the benefit of list over vector. Now, in list, you have two ways of extracting elements. One way is when you want to retain the structure of a list, when you still want to have a list as the output. And the other way is when you just want to extract one of the elements of the list. And now that you've extracted one element, you don't need more elements. You don't need to retain the list format. So when you don't need to retain the list format, you do a double square bracket. Like here, this thing.
All right.
Right? Double.
Understood. Yeah.
Yes. Yeah. Okay. Yes. So this is new relatively. It's a new topic. Definitely give it some practice. But yes, so this is definitely a good question. Um, so, so if I do this, yeah. All right. So these are the ways in which you can still retain the list format. And these are the ways in which you do not get the list format.
Thank you.
All right. Okay. Next thing. So these names that we just saw. So if you just want to have a collection, you now want a vector with just the names. So you can do this, names of the list. So if you write names of V, you get those names as a vector, right? Because it's more than one, so they're combined as a vector. If I do that on W, which did not have any names, then you get null. Now, so this is the names. Now, if I want to extract one particular out of all of this, I can just write the index of that, right? So if I execute line 93, then I just get E1 because that's the first element of the names V vector. Now, this is something which we've not seen earlier, but this would work with any vector, for example. So to actually show you before that, so we have this vector B, right? Okay, so this vector B that you have here, if I write vector B, if I want to change one element, let's say instead of this third element being 13, I want it to be 100. So I can do it this way. So you see what happened here? I replaced an element using its position. So what this line is doing, that third element of B, assign 100 to that. So now 100 becomes the third element of B. So this is exactly now what I'm doing here. So names of V is this. Names of V's first element is E1. Now I'm saying that instead of E1, you write element 1. If I do that, then names of V changes. So if I write V
Understood.
here, so you see the first one got changed. Everything else is the same.
So, ma'am, we can like do anything. We can add anything, like not in the element. We can add also like a one vectors or whatever we want.
So this
Like,
is a name, right? So this has to be in double quotes. Name is name. Name is has to be character. So this is the name. See, this
Okay.
is the general thing that you do in a vector. You can
Hmm.
change something in a vector to something else by specifying its position. I'm using
Ma'am,
that for, yeah.
yeah, ma'am, my question was ki like if we are adding B3, it's 100. So
Huh.
same like in place of B3, we are adding a vector, like any vector, let's say C3 column 5. So 3, 4, 5.
Ah,
So
oh, yes, yes. I think you should be
mm,
able to do that.
yeah,
So let's see if it's 3 colon 5. Sorry. So this is B. So it gave you a warning.
no, C column 5. It's a vector. So no, not 3. C, before like a C bracket 3 column 5. It's a vector only.
Sorry, I could not hear you. Say that again.
C, like how we can define vector C? Yeah, C,
Uh,
small bracket,
hmm.
3 colon 5.
So 3 colon 5 or with or without C, it's still the same thing. So this
All
and
right.
this, these are same things, right? This is same.
Okay.
So the thing is now what we are doing is I'm saying that now add 3, 4, and 5 to the third position of D.
Yes.
So again, we are adding 3 numbers instead of 1 number.
Okay.
So it
So
gives
here
you a
they
warning.
saying ki multiple replacement length is not possible.
So
Okay.
it's a
So
warning.
uh, uh, so if like if we are giving not here also given 3, then might work. Yeah,
Yes.
1 3.
Yes.
Yeah, then it's fine. Okay. All right. Understood, ma'am.
Yes. Okay. Good question.
Mm. Thank you.
So I'll just, for the sake of writing, I'll just write this. Okay. All right. Maybe what we can do is just some random numbers. Mm, all right. Okay, fine. So yes, so this is how you can exchange in a vector. And using that same concept, we can specify a new name for the names of our um, list, names of the elements of the list. Now, if you remember, so W did not have any names yet, right? These were not names. And now you know that it should have 5 names, right? Because there were 5 positions. So if you directly just give it 5 positions, 5 names, and sorry, if you just give it these 5 new names, then if you see what W looks like, so you can see now it's gotten these new names. Okay. So yes, so all of this is possible. Again, how useful it is and where is it exactly useful, it comes with usage. If you're working with lists and somehow you've called it something or you realize later on that maybe there's a spelling mistake, then you can change, you can correct it using these methods. All right. So next up, there's one more thing. So just like we saw this example here, right, that you can exchange a vector element with something else. There is one more way of defining a matrix. So we've seen that you use the matrix command, right? This command. You write matrix and then
Yes.
you give a vector
Mm.
and then you write n col, n row, and then whether it's by row or by column. Now there's one more way in which you can make a matrix. So let's say if you have the vector P, and what I'm doing is instead of making a matrix, I'm just saying that so if I write dim of P, which stands for dimensions of P, it doesn't have any dimensions right now because so a vector or a single element doesn't have any dimensions. In R, dimensions begin with 2-dimensional things, right? I mean, dimension is for 2-dimensional things, whether it's a 3 by 2 matrix or a 5 by 6 matrix, something like that. So what I can say is make this P, make its dimensions to be 3 comma 2. So that's 3 rows and 2 columns. Now if I do that, so now you see what happened to P here. P is a matrix. It got filled column wise. So you don't have the choice of filling it row wise. So by row option is not there. It has to be by column. But you were able to do that anyway, right? So we did not use the matrix function, but just by changing the dimensions of P, we were able to make it into a matrix. So here what this says is that we are changing the vector into a matrix. Now, using the same concept, we can convert a list into a matrix-like arrangement. A list will not directly become a matrix. You can unlist it to become a vector and then make it a matrix, but you can make it into a matrix-like arrangement. But the condition is that each element of the list must have length 1. For example, if this is a matrix Q, this is a list Q. If I run this, so what it looks like, it has these 4 elements and each of the elements just has 1 element in it. So the length is 1. Now what I can do is I can do the same thing and I can say, I can specify the length of Q to be 2, 2 because there are 4 elements. So I can say, let's call it a 2 by 2 matrix sort of a thing. If I do that, so you see, there is no change here. Q still says that it's a list of 4. But when you look at it, it looks different. Sorry. So you see, it looks different. It doesn't, it looks like a matrix. It says it's a list. So now I don't know how do I access some element. So let's say if I want to access this element here, if I want to access high here, in the original queue, this was the 4th element. Now here it looks like it's the 2 by 2 second row, second column element. What do you think I can do to access this element here? Do you think what could be the way?
I'm like uh, bracket 2 comma 2. Like if you are writing x,
2
yeah,
comma
2
2.
and then 2.
Perfect, right? So as we have seen previously, when you have just a single square bracket, it retains the list format. So it retained the list format here,
Yeah.
right? Now, in the original thing, as per the original list, this was also the 4th element. So if I write 4 here, I still got the same thing,
Same, yeah.
right? So it's doing both. So now I have an additional way. And of course, I could do the same thing if I have like the double square bracket. If I do that, then using both the ways, I got the 4th element without its list formatting. Yeah, of course, this is for the previous list. That's not going to work. So yes. So both of these things work, right? So now if you give a different dimension, it's still a list. It can still be accessed by everything originally, but now you have an additional way of accessing it. All right. So, all right. This is not something very essential, but it's just worth talking about because we've been talking about vectors a bit in this class. So this would come handy in the next few weeks. So just bear with me. So if I have this vector D here, okay, sorry. So this vector D, I have a few like odd numbers here. So try not reading the comments that's next to each line. Can you tell me what this would do? If I write D greater than 4, don't read the comments. Think about what it's going to do.
So it will be changing like whatever be greater than two, more than true, other is false. Like false, false, true, true, true.
Correct. Right? So for each of my elements, it checks whether that element is greater than 4 or not. Now, if I do a sum of this output, so if I'm doing a sum of this thing, the highlighted thing here. So what is a sum of false, false, true, true, true? What do you think?
Means like
Sorry,
some
say
of
that again. Your voice is
you're talking
breaking.
about one, two, two. You're asking about sum be greater than four. So
Yes.
5, 7, 9. So 5, 7, 12, and 9, 21.
Okay. Good thinking. But I am doing a sum of this thing. So what I've highlighted here, not this highlight, but this highlight. So if I'm doing a sum of this thing, so basically if I write this, false,
Then
false,
to ma'am,
true,
true,
true.
true, true, true.
If I'm doing this, if I write this
Okay,
statement,
okay. So, okay. So it will be TTT.
no.
It
So
will
I'm
add the character.
okay, no. So sum always does numbers. Okay, sum is always about numbers. So,
Okay.
mm,
So
does anybody have any idea on this? You can just guess. It's okay. You can be wrong, no problem. Okay. So, yes, so as I was saying, sum is for numbers. So false is considered to be 0 and true is considered to be 1. So if I'm basically summing up 0, 0, 1, 1, 1. So that gives me 3. Okay. So if I'm doing a sum of this thing, that would give me 3. And basically, what that 3 is indicating is that how many elements satisfied that condition that I was doing initially. So the condition was d greater than 4. How many elements are satisfying that condition? So that's what sum is going to help us. So if you are interested in finding how many trues are there, then you can do this. Okay. Now, if on this thing, if I write this line, so is which d greater than 4? So which is generally about indices. So can anybody tell me what would this be meaning? Any idea?
in, indices means ma'am, D greater than 4. That means 3, 4, 5. That's
Correct.
indices.
Correct. Absolutely. So, yes. Now, if I enter, so now I have two options. If I write, sorry. Wait. Uh, if I write this, what do you think this would give me?
Same 3, 4, 5.
Think about this. So this is almost like 3, 4, 5. But when I'm writing D and then within square bracket, I'm writing this. Okay. Before I write this,
No, no.
can you tell me what would this give me? This thing. Again, sorry. Small
True,
thing.
true, true.
This is simple vector. Within vector, forget true and false. Within vector, I'm writing the positions that I want.
3, 4, 5.
So this is my vector D. I want to extract third,
three,
fourth,
four,
and fifth
five.
position.
Then 579.
Correct. Yes. So this was meant to confuse you. So it's okay, but this is the exact thing that we've been doing up until now, right? The same thing that you talked about here. If you want to extract things like, right? So it's the same format.
Yes.
So
Mm.
if I am just writing this directly, so I get the third, the whatever those positions I mentioned. Now this gave me 3, 4, 5, right? So if I write this whole thing within D, then it's going to give me 5, 6, 7. Sorry, 5, 7, 9. Because the output of which is 3, 4, 5, and I'm writing that within D. So that gives me D 3, 4, 5, which is 5, 6, 5, 7, 9. So this is giving us which position, sorry, which elements are there which are satisfying that condition. This is a little bit confusing. I completely understand that. But this
Understood,
is
ma'am. Yeah.
but this is how you build up, commands within commands. You can write it in 4 different lines. You can write it all in one line. Right? And the same thing is this. So D greater than 4 is what I was talking about here. So this is D greater than 4. Right? D greater than 4 gave you this. False, false, true, 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 which is this. Now, if I write within D, if I'm saying, so it's basically asking me that within D, you don't pick the first position, you don't pick the second position, but you pick the third, fourth, and fifth position. So when you're picking these 3 positions, you still get the same values. So this is also telling us what elements satisfy the condition. So both of these things are telling you the same thing, same output. All right.
Yes.
Okay. All right. Now we move on to the next thing. So now I think we've sort of done with the major thing is done, but there are a few smaller confusing things here. So now we'll talk something about factors. So this is, if you've heard about categorical variables or grouped variables. So let's say when you are, it's the example is like if you're taking a poll from a group of people about, let's say, what their favorite color is. Okay. So let's say you are asking 100 people, but there are not going to be 100 different answers. Maybe there's just going to be 7 or 10 different answers. Okay. The same color is going to appear multiple times. And most likely what you would be interested in later on is counting how many times each of your elements is occurring, right? So you would like to understand, you would like to group that data, you would like to call it a category, you would like to call it a factor. Okay. So suppose suppose this is like whatever the number of the whichever days in a month it rained or something. So it rained on a Monday, it rained on a Tuesday, it rained again on a Monday, on a Friday, Saturday, Thursday, and Monday. Whatever these um, things indicate. Let's say I save it in a vector E. So I have these 7 elements. Now I can just simply write factor E. So instead of like factor of a variable of a vector. So if I call it F1, I do that. And now you can see F1, it's saved as something like this. Factor with 5 levels. So we'll see what's happening here. If I write F1, now E as such, if you would have just written E, you would have got this as your output. Right? Now, when you wrote F1, you got 2 lines in the output. The first line is that thing itself, whatever was the original thing. So Monday, Tuesday, Monday, Friday, Saturday, Thursday, Monday. So it's in that same order. But what you see is there are no double quotes anymore. It's not considered as a character anymore. And now in levels, it so there were these 5 unique days, 5 unique words were there. So now you have 5 levels. And you see these are arranged alphabetically. They are not arranged in the order in which these came here. Okay, these were arranged in alphabetical order. So F came first, then M, then S, then T, H, then TU, like that. So levels are unique elements. They are arranged alphabetically. But I, of course, I don't want to consider Friday, Monday, Saturday, Thursday, Tuesday. I don't like this order. I would, if I have to make them as some factor, some levels, I want them to be in a in the order in which they come in the week, right? So then what I can do, instead of defining just factor E, I'll say factor E, but also I'll specify one more argument within this function, and I'll say levels. It's this. So I'll write another vector and I'll specify the order in which I want it. So Monday, Tuesday, Thursday, Friday, Saturday, in that order. So when I do that, and if I see what F2 looks like, so see the first line would obviously stay the same, whatever the first line was. But now my levels are in order, in the order that I want them. Okay. Now, I am definitely missing Wednesday here, right? So what if, let's say if it was days that it rained, so what if it did not rain on Wednesday? But I'm still missing Wednesday here. My levels should still indicate Wednesday, right? Because what if I do this recording next month and then I will definitely get a Wednesday? Most likely I'll get Wednesday in that, right? So what I should instead write, my levels don't necessarily have to be just these elements. My levels can be more. So my levels, let's say I add Wednesday to this. So when I do that, I do not get any error. And instead, what you can see here, I got this factor with 6 levels. So these are the levels. I have Wednesday here now, even if it was not in the original vector. Is this clear up until here? Your voice is breaking. I cannot understand at all. Okay. Pavitra, are you okay with this? Do you understand? You can just give a thumbs up or write it in the chat. Okay, I'll assume it's all okay so far. Mm, Okay, so now here, for example, I had used these short notations for the days of the week, right? But what if I want to still have the full name somewhere? So what I can do is just as the order of levels, I can specify my labels which match it exactly in the order. So if I do that, what it's going to look like, F4. So you see now, my levels are these new things. So this one is exactly the same as the previous one. F4 is exactly the ordering and everything is like F3. However, both in my original vector and in the levels, everything has been changed into the full form. So it's like an easy way. If you don't want to change in the original vector, you can specify as labels and then R does the exchanges. Any questions? Okay. Um, so this was the function, the command factor. Okay. There's also another command as dot factor. So if I just do like a general thing, if I don't specify any levels or anything, they behave the exact same way. So as dot factor and factor. But when I want to specify levels, then that thing I can only do using the factor function. As dot factor will say error, unused argument levels. So just be careful to not use as dot factor. Just use factor for both. Like factor is the safe option. You can use as dot factor when you're not using any labels, any levels, nothing. So just a single thing, just the simple version. But stick to factor so you'll not get confused. So here we took the example of alphabets, right? Words. So the default ordering of factors or the default ordering of levels is alphabetically. So A comes first, Z comes at the end. But you can also do factors for numbers, right? So if I have this instead, so for numbers, it's going to be in the ascending order. So 0 up until whatever the largest number is. Okay. All right. Now, in addition to factors, there's something similar but a bit different, and that's called ordered. So ordered is the function name, and generally ordered is another type of factor, but in which the ordering shows something. So if I write s dot fact here, so you see what happened? It has this inherent greater than less than symbol, so the ascending order. So this can be important sometimes when the ordering indicates a trend. Okay, when you're doing something alphabetically, you may not that so here light, strong, moderate, if I write it alphabetically, it's going to be L and then M and then S, right? So light, moderate, and strong. So it's still in that order. But it's not necessary that whenever I'm using alphabetical order, it would indicate something. But here, light, moderate, and strong may indicate whatever, coffee or something, right? So it can be useful. So it's another next level of factors. Um, okay. So so class, we've seen, I think we saw it a few weeks back, but anyway, class is something going to tell you what sort of data it is, right? So class for F1, it'll say it's factors. Class for X, it's going to tell you that it's a list. Okay. Class for M, it's going to tell you it's a matrix. Now, for factors, if you want to not have it as a factor anymore, if you want to remove something as a factor, then, oh, sorry, not remove. Okay, wait. I got confused. To remove factors, there's some other function. I'm forgetting what it is. Okay, so what unclass is basically doing. So you see what F1 was. Okay, now imagine this levels has got some order of 1, 2, 3, 4, 5. So consider Friday is 1, Monday is 2, Saturday is 3, Thursday is 4, and Tuesday is 5. Right? So if that is the case, then you see this Monday, so this becomes 2. So that's 2 here. Then Tuesday, that's 5 here. So that becomes 5. Then it was Monday again, so that's 2 again. Then it's Friday, that was the first in the levels, right? So that's 1, and so on. So when you're doing an unclass, the actual elements are replaced with the position of the factor that they represent. Does this make sense? Yes, no, maybe.
Yes, yes, ma'am.
Yeah, okay, all right. So, right, again. Okay. So this was um why did I write E here? I don't need E. Okay. Um so now you see F3. Why would this work? Hmm. Okay. Okay, this one is a little bit complicated. Um, so you remember what we did here in F4? So whatever was in levels, we wrote the same thing in labels, but the full form, right? So levels and labels have to be in the same order for R to correlate them, right? Now, um, so F3 here has these um, levels, right? If I want to add labels to it, this is another complicated way of adding labels. So basically what I did unclass of F3. So when I do that, I get this, right? Because this was the order. And then Mondays, okay, 1, Tuesdays, 2, and then Mondays again 1. So I get this order. And then I say days, get this thing. So it's basically correlating these with whatever was there in days. And then uh, in F3, whatever was the order. So this was the order. And then now instead, you got these full names. I'm not sure if I confuse you more. This is not super important, but so this is just how it's working in R. I might not have done a good job explaining this, but practice it. Maybe it'll get clearer. But if not, it's okay. It's supposed to be complicated. Okay. Just a few final things. So the last lectures for this week was very different. Um, so whenever there are these two functions, print and format, that you can use in R to format your outputs sometimes when maybe when you're writing text or when you are using something, for example, maybe in a plot when you want to specify or for them to be in a particular formatting, these can come a bit handy. So if I simply just print 22 by 7, so they're going to come in a particular format. It's going to look something. Now you can specify how many digits you want. Now when you say digits, you mean digits, not just decimal places, but how many digits you want in your answer. So you specify 4. Now we can take this example. I'm not sure what it's going to do. If let's say if I write this. So of
Yes,
course,
recurring, ma'am. Like if you're doing a recurring thing, like 10 by 3, it's about 3.333.
uh-huh.
So, so then in that case, how many digit it will print?
Okay, so let's take this example. So this thing, so
Okay, only one digit.
so it printed a total of 7 digits in either case. Maybe let's make more zeros here. So, So basically
I
what
think,
it's
ma'am,
doing, so
yeah,
yeah, so basically what it's doing is it will try to print up to 7 digits only. But if these are before decimal, then you obviously have to print everything. You can't miss the units or tens places. But if it's already going into decimals, then it would only print up to 7 total digits. So you see here, 22 by 7 is a single units place, and everything else is decimals. So it printed up to 7 total number of digits. So 3, 1, 4, 2, 8, 5, 7. These are 7 digits in all. And when I'm doing this value, so here this is what 7 digits are. So it just stopped after one decimal place because it said that, okay, total is 7 now. But when it's a very big calculation, you cannot obviously have it smaller than whatever, like even except the decimal place, you have to have that whole integer value, right? So it does that, but it no longer prints the decimal because we have already exceeded beyond 7. So 7 is like a limit. But what we can do is we can specify how many digits we want. So if I write digits is equal to, let's say, I don't know, 15. So it prints 15 digits.
all right.
Yeah. So again, so this is how R works. So maybe if you don't want, see, this is also something which you might have come across in Excel. Sometimes when you're doing some calculations, Excel is going to print like 10 decimal places. But when you have 10 decimal places, it's not very readable, right? And
Ma'am,
yes. Hello.
for the
Your voice is breaking again.
uh,
I can't hear you. Sorry, Aditya,
sorry,
absolutely not audible. You want to maybe type your question? Okay. In the meantime, so let's say if this is a vector, it's saying something. So if I just write print L, so it's just printing each of my elements, right? So these are 5 elements. This is a normal character vector, right? If I write format, then you see what it's doing. It's changing each of my elements. So it's adding some spaces to each element. And it's adding as many spaces so that each of my elements now has the same length. So September, it has 9 elements. Now this one also, if you count, this one also has 9 elements. So each of this has 9 elements now, right? And now there is obviously some sort of a spacing here and there. So you can specify how you want it to be arranged. So if justification is none, justify none, then it's back to no extra spaces added. If I say justify center, then you see each of them is in its center now. And if I say, you can specify how long you want it to be. So, sorry, you can specify how long you want it to be. So now spaces are added in all of them. Even September now has like this one space before it and 2 spaces after it. And I think the final thing here, so um, so there are these two number formats. One is a scientific format and one is like a normal format. So if I say normal format, when scientific is false, then it's just this number directly. Wait, let's write it this way. And when I say scientific is true, then you'll obviously have this, the exponential version, right? So 1 into 10 to the power 10. So E plus means, so E here means exponent. So maybe I can just change it to here. It might be a little clearer. So this is how it is. So there are 10 zeros here. Yeah, so 10 zeros, so E to the power 10. And if I say, so there's something like this big mark, comma. So when I say big mark, comma for the non-scientific notation, then it's going to put commas at these thousandth and millionth and billionth positions. And when you have a scientific notation, then obviously that doesn't matter because scientific notation doesn't have these commas or big mark thing.
Ma'am.
Yes.
Sorry, that I was asking,
Hmm.
like we are giving a digit equal to 15
Hmm.
earlier.
Mm-hmm.
So is there any mechanism like we want uh like up to 3 digit?
Three
Because
decimal
here we are
places, you mean?
giving here we are giving digit 15. That depends on our
Answer.
observation, because like
Yes. Yes.
after, so
Correct.
can any mechanism like we want up to 3 digit or up to 4 digit? Because if we are doing a scientific calculation, then we need
Hmm.
up to 4 or 3 digit.
Yes. So I think there was this function round that we saw initially.
Mhm.
So this one, round takes the value and it's, yeah, so round and truncation and floor and ceiling, these things we had seen, right? So floor and ceiling anyway, they're for integers, but um, round I think is something which we might need, but I'm not sure if the print function itself has this option.
All right, ma'am.
Yeah,
I'll share.
you can check. You can
Thank
check.
you, ma'am.
Yeah. Yeah. Okay. All right. So yes, so this thing was there. Um. Ah. Oh, this is your question. Oh, it's here. So n small means how many decimal places? I'd forgotten about this. So yeah, so this shows how many decimal places you
I
want,
got
right? So print has the option of digits and format has the option of decimal places. But format also has digits. So if I combine both of them, right? If I have this complicated thing and I have both digits and decimal places, then what's going to happen is um, decimal places has a higher preference. So digits would only say that you truncate it. Mm, wait. Yeah. It's not truncation, it's rounding off again because you see it rounded off here. So total 6 digits. But if I say have maximum 6 digits and also have 10 decimal places, then decimal places has a higher preference. So it would still have 10 decimal places rather than 6 digits and all. But there's a restraint. So you can only have 20 decimal places. If I have 21 decimal places, then it says it's invalid. However, I was just checking something. Even if it's like 20 or 19, it's adding this some random digits at the end. I was not able to determine what is happening here, but yeah, something is there. But the main idea behind all of this is that the format function can help you with how many decimal places or how many digits you want and all. Um, yeah, so that's pretty much what was covered this week. It was a lot of content. Everything was almost new, and I do have some practice questions. Um, so let's. Do you have any questions before we jump to the practice questions? Okay. Um, all right. So if I have this list here, um, if I have this list X, wherein I specify the name for the first element, but I don't specify a name for the second element, and that's a list. What command would you use to assign the name x2 for this to the second element? So we've seen this in today's class. You want to try? Okay. Mm, I will write it then. So the first thing is you want to say names of x, and then you want to extract the second position out of it. And then that second position, you want to call it x2, right? So that's how it's going to be. Okay. All right. So now we have a list which has 7 elements. These are the elements. Um, the first 4 elements are single elements. So all of these are single elements. The first 4 are characters, the next 2 are numbers, and the last one is also a character. So what will be the correct output of the command append x comma 200? And the other one is what would be the correct output of the command append x comma 200 after 4? So would the output still be a list, or would it be changed into something else? You can maybe unmute yourself and try. Okay. So of course, both of them, the output is going to be a list, right? So list of 7 elements, both of them. I'm not writing the entire thing, but of course, in this case, your basically your 7th element here, that's it's going to look something like this, right? For this one. And in this case, it's after 4. So your 5th element, I do not have my pen with me today, so don't mind the handwriting. So the 5th element here, that's going to be 200. And of course, then you'll have your 6th element and 7th element, and the 8th element, of course. So this is going to be 8. Yes. Okay. It's list of 8 elements. You already have 7 elements in this. Yeah. Okay. All right. I hope this is clear. All right. So now there are these 2 questions. One of them is using the command factor. The other one is using the command as dot factor. Now remember, both the commands behave same when you don't specify levels. But when you want to specify levels, then as dot factor doesn't work. You just have to go with factor. So in this case, since you don't specify levels, you're just okay with whatever the default is, both of them would work fine. There's not going to be any error, but you can just, so the same funda holds for both the questions then. There's no confusion. So, but can you tell me what the output is going to be? So basically the first line should have the input as it is. And the second line should have the factors, that is each unique input once. For numbers, it's going to be in the ascending order, right? So in question number 4, it's this. So the first line is the exact same input, and the second line for levels is unique numbers in ascending order. So that's this. And for this one, again, same thing holds true. So this is your input numbers, and this is them in ascending order. So that's the right answer. Okay. So what is the correct outcome of the following commands? So now, remember, so this whole set here, the first line is you're specifying a vector data. The second line is you are making a factor data, but you're not saving that factor data anywhere. So data is still a vector. It's not yet a factor. You get, so in this output here, you get data as a factor, but for the next line, data still remains a vector because you're not overwriting data. So definitely the first output here, that is data as a factor. So that definitely is going to be, so this looks correct, right? And this also looks correct here, right? But these two, they're definitely not correct. Then the next here, you say that levels of data are A, B, C, D. So now, since data is not a factor, so the ordering is not going to change. So 2, 4, 6, 9 is not going to happen. It's still going to be 4, 2, 6, and 9. So it's still this way, right? I mean, you don't have them in as a factor. So the ordering is still going to be exactly what it is. So data has not become a factor. These original numbers are still going to be there. So it's still going to be this thing. And you're just specifying levels. So we've not seen this example explicitly in today's class, but it's, again, it's not, I think you have a question like this in your assignment. I'm not very sure, but if there is one, then it's just going to help you understand that question better. Okay, but still try to type this into R and see what it's doing. Okay, and now I think I have this one last question. This is a little complicated. So first of all, there are a lot of brackets here. So what can help you is, so this is one bracket. This is the closing bracket for that. And this is the next bracket. And then let's say this is the bracket for, okay, I did something wrong here. So this is that closing bracket for this one. And this is another opening bracket here. Okay. So now basically what we are doing, so within the factor function, you are specifying this vector, high school, graduation, post-graduation, and so on. And you're specifying the levels as high school, graduation, post-graduation. So that's easy. Now you're doing an unclass on that. So now if you remember what unclass did, so definitely here, the last line, so you can eliminate options here. So the last line is definitely going to be this thing. So it's either this or it's either this, right? High school graduation, post graduation. And then you're doing an unclass. So basically, it's going to write the order of elements in the order in which their levels come. So high school, that's level 1, so you get 1 here. Then graduation, that's 2, so you get 2 here. Then post graduation is 3, so you get 3. Then graduation is again 2, so you get 2. High school is 1, you get 1. Then post graduation, then high school, and then post graduation again. So A is the right answer. All right. So again, there has been a lot of new things to a lot of new things have been introduced in this week. So definitely give it a good revision. See the lecture videos if you already haven't, and I will upload the PPT for these questions and of course the script. And please definitely go through it. Try to run the commands and see where you're getting stuck. Try to predict what the outcome is going to be and see if that output is correct. If you do have any questions from assignment 7, let me know. The solutions were released, I think, just yesterday. But anyway, even if there are some questions that you have not been able to cover today, you always have the discussion forum for the course. And yeah, the recording will be uploaded to YouTube. The PPT and the R script will be added to the Google Drive for reference. You have the link to the Google Drive via your NPTEL page. The assignment for this week is the 18th of September, next Wednesday. And we can have the session for week 9 on next Friday at the same link. So I think that ends today's session. Do we have any final questions from anybody? Okay, so if not, then thank you for joining. I'll see you next week then. Bye-bye.